everyone.
Okay. Testing. Is it good? Okay. All right. All right. Good. Introduce yourself.
So I guess just to introduce myself, I'm Ahad Bashir. I'm a computer science master's student at Brown, and I'm currently working at the SEI with Anushah.
Hi, I'm Anushah Hossain. I'm a researcher at UC Berkeley, and I'll tell you in a second about the project we're working on. And our presentation today is called Encoding Expectations. How long does it really take?
Oh, yeah. So we're both part of a project called the Script Encoding Initiative, or SEI, at UC Berkeley. SEI works with script community representatives and experts to get historic and minority unencoded scripts into Unicode. In our work with script communities, a large part of our job is to do expectation management. It's rightly frustrating when one can't use the preferred characters or scripts on a digital device, or even just getting it available in the Unicode Standard can also take years. However, this project was then born out of the question of how long does it take to get these scripts encoded into Unicode. We decided to pull together a plethora of publicly available information that Unicode publishes to double check the rough answers basically of how long does it take to get scripts encoded. We began this project just a few months ago. So these are basically just some first passes on what we found so far. So please take it with a grain of salt and please give us any suggestions you guys have for improving it later. Anyway, so over the course of this talk, we'll basically be sharing some high-level observations we made along the way on how the standards evolved over time, what scripts are represented, and what proposals generally look like, including how long they take and so on before wrapping up. And then I guess with that out of the way, you can go ahead.
Yeah, so we'll begin with a review of the Unicode Standard for just some scene setting. So as you know, between 1991 and 2024, 16 editions of Unicode have come out. So you can see here on the longer lines, the 16 major releases and the intermediate releases interspersed between them on the shorter ones. So in the early years, there are many more intermediate releases, but in the last 10 years or so, Unicode has been putting out major releases roughly on an annual cadence, with one exception last year. So let's go through a couple of milestones to get a sense of the project's progress over this time. So the first release was in 1991, but it was in 1993 that the Unicode Standard and a contemporaneous standard called ISO 10646, an international character code, became synchronized, meaning that the two standards were essentially the same and they're synchronized to this day, but Unicode does contain some more data to help with implementation. Another big milestone was in 1996 with version 2, when the original 16-bit restriction that limited Unicode to about 65,000 characters was lifted, giving us much more code space to work with. And then version 3, released in 1999, is what most Unicoders will consider the first production-ready version. So this had every national script and most commercially important scripts in it. And it was also at this stage that major software systems like Microsoft Windows began implementing Unicode. So it's kind of a turning point when it felt like this project really became real and was starting to get adopted. Still, it took a little while for the standard to catch on. So another milestone that Unicoders will tend to note is in 2007, when Unicode became the most commonly found encoding on the web, overtaking ASCII and Western European encodings that were popular up until that point. We can also note the progress in some related text technologies along the way. So these are just a couple hand-picked examples, but you could put many more on there. So one milestone is in 2002, when the Script Encoding Initiative, which we're part of, was founded by Debbie Anderson to help smaller scripts get into Unicode. And some other ones just put on here are in 2012, when Bid.Esfabad redid the open source shaping engine called HarfBuzz, calling it New HarfBuzz. And this was really important in making it much easier to handle complex scripts and software. In 2015, Microsoft released the Universal Shaping Engine designed by Andrew Glass, and that was also very important in speeding up the process to add shaping support for minority scripts, especially when they didn't match the pattern of existing scripts or script families. And then you can also note in 2016, the Noto open source pan-Unicode font was first released, and so on. We didn't have room to put on more things, but you can think of other milestones in font technologies like the invention of OpenType and advances there, or the release of Keyman for building input methods, etc. Okay, we'll just quickly look at how many scripts and characters were added to Unicode through this same time period. So this is a chart of the number of new scripts added in each edition. You can see that on average, about 6 new scripts were added per version. And there are some peaks in version 3 and the different version 5 releases. And then again in version 7, when 23 scripts were added at once. And this is a chart for the characters added, the net gain in characters added per version. The axis goes up by 10,000. So you can see that the median number of characters is around 3,500, but you have some outstanding cases such as version 3.1, when the net change was nearly 45,000 characters, new characters. If you compare these two graphs, you'll notice that the peaks and troughs don't match up exactly. You have the scripts again on top and the characters on the bottom. And this is because there are times when a large chunk of character extensions were added to an existing script. So that doesn't necessarily mean a new script, but many more characters, such as the Han ID graphs added in 3.1. Okay, so we have a little bit of a sense of how Unicode changed during this time. We'll talk about the scripts that were in Unicode now.
Yeah, so first, if we look at what we have up there, we can see how the 168 scripts that are currently encoded in Unicode are kind of split across geographic regions. So notice that you see about like 50 from South Asia, just over 20 in Europe, Middle East, and Southeast Asia, about 50 in Africa. And then you can also compare these to, how many scripts that we know of that are still left to encode in all of these regions. So if you'll notice by looking at this graph that there's pretty clearly a really strong focus on South Asia, for example, which might be warranted as that region also has, as we can see, the most scripts that we know of basically of anywhere. But it's also very clear that like other regions seem to be particularly underserved, especially in Africa, as you can see, or the Americas. A lot of those scripts are still unencoded to this point. So that's something to consider going forward. Beyond that, we can also take a look at the different script types. So we're showing this like graph from Wikipedia to kind of look at what we have here. But in general, this is like a map of the distribution, and these are like the types here. So you see, for example, that alphabets are kind of used everywhere around the world. But past that, logographs and syllabic scripts are generally just kind of used in East Asia. But there's also some examples in the Americas. Beyond that, prominent abjads are in the Middle East, while abjadas are also quite spread out, but there's a pretty significant concentration of them in both South and Southeast Asia. And then we can also see the percentage breakdown of the script types. As you might expect, you see nearly equivalent portions of abjada and alphabetic scripts, which are making up by far the biggest majority on this pie graph here. We also don't have this graph handy to you, but you can also imagine that if we did this by character count instead of just by script count, you might actually find that the part of the pie that's made up by syllabary scripts would actually be a lot larger, because on general, those scripts have a lot more characters per script compared to the other ones. Past that, looking here at script direction, so as you might see, the vast majority of scripts by far are left to right, and then the biggest chunk after that is right to left, and it really falls down after that. And then a lot of things are like unspecified, or like Bustafidrin, for example. I always mess up saying that one. They're all put into the other category. And then verticals, just if there's any vertical components, how we split it up. And then also, this is the split of living and historic scripts, where living just means it's a script that's still in use. And historic means one that's just historical. But a great deal of historic scripts are also in there, which is pretty interesting, because originally the vision for Unicode was that Unicode was not to be used for historic scripts and was supposed to just be for like living scripts that need to be used on the internet. And we can also compare what's left in code with these categories, and we'll see there's relatively a lot more left to do on the historic script front. We also see that like clearly we're about only halfway through, I guess, like the entire Unicode project if we're aiming for full script inclusion in Unicode. But on the other hand, it is also worth noting that doesn't mean that Unicode is underserving a large portion of the world, but it's a lot of smaller, either historical scripts for a few scholars, communities of scholars, or smaller communities of users that make up the large portion of the remaining scripts. Past that, there's a few examples of websites that you can also look at for exploring other scripts if you're curious about stuff like this. So for example, there's World's Writing Systems, which you can kind of sort by like the region or the name or like when it was added to Unicode. And you can see more information like the script type or script region like we were saying before. Past that, there's also decodeunicode.org, which is similar, but it gives you a lot of the kind of like metadata that you might see in the code point and so on about like specific characters in Unicode. And then past that, there's this one website, hyperglottic Rosetta type, that's a lot newer that kind of gives you a similar idea to decodeunicode.org, but it also gives you information that's kind of organized by region, and then also like the specific languages that use those scripts and how they use them differently. And I can pass it to Anushah for on proposals.
Great. So we've covered Unicode, we've covered scripts, so now let's get into the proposals. This picture, by the way, is from an exhibit in the Netherlands that some of our colleagues did, where they printed out all of the proposals that had ever been submitted to Unicode, including unfinished projects, and just laid them out across this whole room. And it was a lot of many, many papers. And you can see some of the stacks there. So a little bit about the proposal process. So for new scripts or characters to be added to Unicode, they go through these few steps where information about the characters is shared with a committee of experts, which is now called the Script Encoding Working Group. It was previously called Script Ad Hoc. And that working group reviews them and passes on their recommendations to the Unicode Technical Committee, which meets 4 times a year. And they fill out, when people submit proposals, they fill out a form that looks something like that. In the early days, it was common for some proposals to be fairly rudimentary, sometimes just a few paragraphs in a code chart. So on the screen here, you see an old cheeky proposal by Michael Everson, a name you'll be hearing more as we go on. And the whole proposal is 5 pages long. There's a bit of kind of opening spiel on the first 2 pages, a few paragraphs of description, and then basically just a code chart. And these types of proposals were accepted in the early days before our stricter process came into being. So this is a more recent example that shows the kind of more concrete template that has now become common. This template includes headings like background on the script, script details, so the name, the repertoire, the script grammar, collation, so how the letters are ordered, character properties, line breaking, confusables, and attestations, which are examples of the script in use. So this is maybe 10 pages from a 70-page proposal from 2014. And it just gives a bit of taste on how much more in-depth these proposals are at this point. So for our project, we thought that these proposals can form a really rich public data set that can help us understand how Unicode has evolved in all these years. So the next few slides will share some descriptions of what successful proposals have tended to look like. In this project, we just restricted our sample to scripts that were included in Unicode 3.1 or later, so after the production-ready first pass, and don't include documents from scripts that are still under consideration or have been abandoned. Okay. So some high-level stats. On average, how many proposals does it take for a script to enter Unicode? We found that the average is 3, and for about 50% of the cases, it takes 2 to 4 proposals. So these are the numbers that we tell communities that approach us. But there are many exceptions. On the kind of lucky side, there are some exceptional examples where the script only took 1 proposal. These tended to be early on in Unicode's history, as you might suspect. Here is a list of some of them that took only 1 or 2 proposals. And you can see mostly they're from 3.1, 5, 5.2. These are also some of the first projects that SEI worked on. There's another small subset, however, of scripts that take 6 or more attempts. Here's a list of the ones that came up. Why does this tend to happen? Why do some proposals take so long? It's not necessarily that they're technically complex, though that is often also true. Most often the delays are due to kind of social or political conflicts. There might be two communities invested in different orthographies that might use the same code points, and they need to sort things out. There might be conflicts over the naming of characters, etc. So that's the type of thing that really drags out the process. And you've already heard in some of the talks yesterday mentions of some examples like Tigolari, which took 7 proposals, and it wasn't even the most stretched out one. For that, it's Old Hungarian with 12 proposals. So those counts that I showed don't include what we call pre-proposals. A pre-proposal is an initial document that introduces the script or a script family. So the example up here is from the Lambda script family, where Anshuman Pandey, a name you'll also hear more as we go on, talked about how this cluster of scripts can be unified, but not entirely. He suggested using at least 2 different encodings to support multiple scripts. I'm going to explain why we couldn't just use one approach for all of them. So that's the type of kind of groundwork laying that happens in these pre-proposals. So we found that about 1 in 5 scripts from the whole set that we looked at had a pre-proposal, which was a higher percentage than we were expecting, 20%. Okay, looking at page count now, you can see that the page count of proposals hovers around 12 pages for the initial proposal, and then tends to grow by about 50% by the final proposal, ending up somewhere between 50 and 36, or 15 and 36. There were, again, a couple of very short proposals early on that basically look like the characters placed on a code chart. And then you have very long proposals that can index one of 2 things. So the maximum here for a final proposal is 697 pages. So why might you have such a long proposal? Most often, it just means the character repertoire is really big. So here's that example, a very small subset of an example from the Tangut proposal. And this is for an ideographic script, and the authors proposed 6,125 characters. So really, you just need all of those pages to go through each of the characters and their properties. Oh, I forgot. It's probably a lot shorter.
Yeah, I don't think it was by far Tonga had both the most characters and pages, I think.
Very much an outlier. But other times, the page count might instead be a proxy for the number of attestations given. So this is an example from Sogdian, where the script only has 22 characters in the alphabet. But I think this was like a 100-page proposal, and 70 of those pages are for images to show that this historic script, that all of the letters proposed do exist, that they're different from each other, so contrastive examples, and examples of how they join together because it had complex joining behavior. So the page count can be a proxy for one of these 2 things. Okay.
So, we can look at some graphs, I guess, but first off, we have how much time does it take, and we notice that a lot of years can pass between the first proposal and the point where it's actually included in Unicode. So you can see there that the median amount was about 2 years, just under. And again, early on, you could also see, like in the graph here, that it would take less than a year for a lot of these earlier proposals. And then, as we said before, those might be the proposals that took maybe just 1 submission to actually work out. But also for about 25% of scripts that did eventually make it in, it took nearly 6 years to get those ones in. So there's a pretty big spread on like how long it can take for a proposal to get in from first proposal to the point where it's actually included in Unicode. So here's a graph of some of the slowest proposals that we have. We have Soyombo, our old friend, Old Hungarian, which you'll remember had 12 proposals, Old Permanent, Warring City, etc. They all took about 13 to 14 years actually to go from first proposal to actual Unicode inclusion. Of course, these are not like common cases and should not set the general expectations, but it's worth noting that there are examples where it can take really long times to go from the first proposal to actual inclusion in Unicode. Also here, a large part of why the time taken can be pretty long for some of these is that there can be long periods of gaps in like time between the proposals. So you had to do a bit digging into the faster cases here. Sometimes you just have two related documents submitted in short succession of each other. You'll see that the minimum up there is 2 days. There's also 5 or 6 examples that we filtered out that were examples where a proposal was submitted on one day, and then the exact same day, that same author would submit another proposal following up, which that's something we have to look further into to understand why they did that, but we removed those. So like minimum besides 0 days is 2 days. Beyond that, you'll see the most common gap between proposals is about 6 months. The median is about 8 months between proposals. And however, there is a top 25% of exceptional cases where it takes over 1.5 years between proposals. And this is between one proposal and the proposal that comes right after it. And just a few or a whole decade actually passes between proposals. We'll see right here at the very tail end, there was one that had 4,743 days between 2 proposals. So yeah, for an example of a long gap, you have Old Permic, where Michael Everson, who is Unicode's most prolific proposal author, which we'll talk about further on as well, submitted a first SIG proposal in January 1998 and January 1999, and then left it untouched for 13 years, and then picked it back up in 2012 when he submitted to RISE submissions in quick succession, and then got it approved for inclusion in Unicode 7.0. We can also guess from like the sparse minutes in 1999 that it was initially dropped because it was a pretty infrequently used script and was important to scholars, which at the time it was hard to judge by the review committee whether to include it or not. So I guess later on it got repicked up and resubmitted. Beyond that, we have a few cases of where the first proposal and the last proposal were actually authored by different people, but that was only in 18% of cases. That you'll see that one group, for example, on the left side where you see initial author started the proposal and then somebody else submitted the final proposal that actually got encoded. However, one interesting thing to consider is that, for example, you have Mite Mayek was first submitted by Michael Everson, but then the final author was Irish National Body and US National Body. But technically, Michael Everson is the Irish National Body. So that's worth considering in that case. Past that, this is a really large graph, which you don't actually need to be able to read. But the important thing to see here in terms of like, if you'll see on the y-axis, it's like number of proposals, total proposals. And then on the x, it's just like all of the different possible authors. What's important to know is if you see on the left side that there's a really significant basically rise, I guess, for 2 people on the left. And as I'm sure a lot of people might be exposed to at this point, it's Michael Everson is the leftmost one, and Anshuman Pandey is the second leftmost author on this list here. So we have a little like pie chart to show that. As you'll see, Michael Everson made up about 55% nearly of all proposals in Unicode ever. Past that, Anshuman made about 26% of them. After that, we have like China at like 4%. And then there's a very significant drop off, you'll notice, after the first 2 of them there. And also this is across all proposals, but when you actually look at just initial proposals, you'll note that Everson actually goes up to 60.8% of all the submitted proposals. And then this is just looking like with Michael Everson and Anshuman Pandey, and then how they are split between which regions they focus on. You'll see Michael Everson has like a breakup of where there's mostly a Middle East, Europe, and then after that some South Asia focus. Anshu mostly focuses on South Asia, making up like 67% of his things. Oh, and then yeah, it's also worth noting that like, combined, they make up 80% of all proposals that result in successful inclusion in Unicode so far. And then beyond that, Michael Everson's scripts in general were about 26 pages in length, while Pandey's were about 42 pages long. On that, we can also look at the gap between what is in Unicode and what's left. And then if we combine that with what we saw, it looks like we probably need more people who are kind of like Michael or Anshu to focus on like Africa and the Americas, basically, where neither of them actually did as much work as they did in other regions. So it would help if there was somebody who was similarly focused in those areas.
Just a quick question.
Yeah.
Are they doing all of the research and making the proposal, or are they proxies for other groups and they're helping them to get the proposal submitted?
It's both. They do co-author with other people as well, and it's very common for them to be consulting other script experts. But there are many, many of you. That's a good thing to look at, how many of them are individually researched, and it's still a high percentage.
In many ways, they're a proxy for other people, and then they help them say, well, this is how we shape a proposal.
Right. It's worth noting that like in this graph here, both Michael Everson and Anshuman Pandey are actually, we count each time somebody's a co-author on something as like one proposal that they authored for this graph. So for example, like Michael Everson and Anshu, they both have like a lot of cases where they're co-authoring with other people. So they count it up really, really high. So it's both like the co-authoring and them taking over the authorship. Can run over here and then actually, yeah, sorry in advance, it's gonna be really hard to see these graphs actually. But one of the last things we wanted to look at, if there was just any patterns in general. So if you see here, this graph specifically in blue, you have like the first proposals with all of the scripts on the horizontal axis and the years that they were added along the vertical axis. So there you have like the trend of like moving up in terms of these blue dots here are the first proposals. If I hit here, you'll see the pattern of the last proposals moving up along, obviously in the same pattern as the blue proposals. Then we have green here is just the proposals in the middle. Yeah, so it was blue is like the pattern of just like first proposals through the years. So on the y-axis you have like years, and then the x-axis you just have all of the included scripts that we have so far. The red is like final proposals, and then green is just proposals in between. So that one's more of a visualization than any patterns or anything, but past that we have, sorry, let's say time, so we didn't really find anything significant in terms of what causes like any patterns in terms of how long it takes to encode or something. So we didn't see a discernible pattern in time to encode across the different regions scripts originate in. So you'll just see that like there's a legend up there that like blue dots are Americas, Europe, Oceania going down. And that's just sorted by those regions. We didn't see any trends on like what region it was and how long it took to encode. Past that, we didn't see any patterns for script type as well, which is like alphabet, abugida, so on. There wasn't any significant trend on its own about like it took longer to encode because it was X script or Y script type. As well as for author, we have, we split it up into Michael's the red dots, Anshu's the yellow ones, and then everyone else is the blue dots. Past that, we also didn't find anything for script status, whether it was doing historic, script direction, nothing was significant, size of the character repertoire, proposal length, SEI involvement, or whether there was a pre-proposal or not. The so for the only thing we found that could seem to be a pattern of sorts was that logo syllabaries from East Asia tended to take 1 to 2 more proposals to get encoded than from other regions. Also tentatively, we looked into this a little bit, but it was also, there seemed to be a pattern of like China national body being involved seemed to also correlate with more proposals until script inclusion. But that's also something that we need to look into later. So in a way, you could also say this confirms the consistency of Unicode script experts, that there doesn't seem to be a significant bias in any way that, like, for example, scripts from the Americas take like 3 years longer to encode or something, which is hopefully a good thing, but it could also be another factor is just that like there's only so many included scripts, so there's only a sample size of however big. So past that, there also might just be other factors at play that we haven't considered yet. Then you should take it from here.
Okay, just to contextualize all of this, this is just a first pass at exploring the bigger question we're interested in of what it takes to take a script from 0 to digital and what helps or hinders that process. So there's a lot more data gathering and cleaning we have to do. And for this, we would like your help. So right now, we've just been looking at Unicode inclusion and what we've presented in the last 20 minutes. But what we would really like is to gather information on font and keyboard availability, shaping support, locale data, etc. And this is so we can continue to explore if there are patterns in what types of scripts tend to get supported faster or slower, and also be able to say to a community with some confidence how long it'll take to see their scripts on their devices, which is really what they want, not just Unicode inclusion, but available on their phones or computers. So these are much bigger questions and require all kinds of information from script communities and from technologists. So we'll just share, we'll close out with a case study of from Adlam of how much information we would really like to have. So these are some milestones that we got from Debbie, actually. So you can see here, Adlam is what we call a neography or a newly invented script from the last 50 or 100 years. It was invented in 1989, and then 27 years passed between its invention and when it was encoded in Unicode in 2016. In that interim period, the Berry brothers, who invented Adlam, built up grassroots support for it. They built digital tools like fonts and keyboards themselves, even without Unicode encoding, and then submitted several proposals until it was finally included and then revised in 2020. So right now, the data set that we've just presented only covers three bullets from this timeline, 2013 to 2016. You can kind of carry the story forward far beyond that. This is a graphic that we borrowed from Neil Patel, a type designer and researcher. And he showed the timeline for two scripts here. There's Unco on the top, which we won't talk about now, and Adlam on the bottom. And it shows the years it took to get full stack support, you might say. So you have Unicode encoding here in the first few dots, but then he shows how in the ensuing years you had support on operating systems, the Universal Shaping Engine for Windows, Harfbuzz, Cortex, and Apple. Steadily open source fonts were built, like Nodo Sans, Adlam, and input method support was added, like Gboard support. So we would love data on all of these steps for all of the scripts that we've been looking at. And so far, this is kind of the one case study we have. So if you work at any of these companies and can help us with that data, we'd love to talk. And that's it. So thanks for your time. We'd love to hear what stood out to you from what we've shared so far, if anything was surprising or shifted your understanding of what is in Unicode. Thank you.
Thank you for that. It's all interesting. But I think and you kind of alluded to the fact that as Unicode became more complex with normalization, collation, confusables, that when you submit a proposal, the criteria has changed for accepting the proposal. So it would be interesting to establish the levels of criteria that are necessary. And also, I think a factor might be the number of experts for a script or a region, because you're collecting data, you're getting testimonials about how the characters are used. If a script has several experts, I'm not even sure if that improves or hinders the process, because you mentioned conflicts, but that seems to be related, as well as the number of speakers, because that determines how many examples you can get and how easy it is to confirm that a proposal is correct. So I think, looking at it from the perspective of what are the requirements, and how easy it is to fulfill those requirements, not just the proposal and how the authoring process goes, would add a lot of clarity to the process. And it would probably also help people who are thinking of submitting proposals, what they have to establish, right? So that's suggestions.
Yeah, great
That's a good
suggestions.
idea.
Hi, great presentation. Lots of work went into that, I can tell. I was mostly curious what drew you to do this research and look into this.
Yeah, we can both answer. We kind of set it up at the start. Working at SEI, we do get lots of emails from communities seeking digitization. And a lot of times people want it to happen really fast, and you have to tell them, no, it'll take many, many years. And I think it's nice to be able to say just how many years or kind of the range that they should expect in their minds. So that's where it started. But, you know, I'm a social scientist who thinks about Unicode and writes about Unicode. And I feel like there's so much commentary that of like low-hanging fruit, like projects that can be done like this, just to help people get kind of an intuitive understanding of what Unicode is. I knew that Michael Everson and Ajahn Pandey were prolific proposal authors, but to see that all of Unicode, like 80% of Unicode they had a hand in, that's kind of a more shocking number than I was expecting. So those types of just producing those types of facts, that's what you're interested in.
Hi. I was just wondering if you had any data on character proposals that are not based on a language, like technical symbols and mathematics.
Oh. We cut those out. We didn't look at them in this path, but yeah, I mean, that's all out there on the document registry. But
I mean,
what do you?
as far as how long it takes to get those kind of things
Right.
implemented.
Yeah, I don't know. And we were only looking at like wholesale proposals for an entire script, not character additions, which is, they take up kind of the same amount of time.
Well, I would imagine they would come in batches as well.
Yeah.
It would be similar to scripts. Okay.
Yeah. You'd be surprised though, they don't all come in batches. So many times you spend an hour talking about one character and then another hour talking about a whole script, right? That does happen.
Yeah, like I think we get a bunch of things that are like, here's an entire set of symbols used by this particular notation from like 1700, and then that will take a long time because we have to kind of go through everything. So it's similar to scripts. We also get a lot of just like, oh, here's this one thing I found. And here's this one thing I found will still take a couple years from end to end, but the proposal review process is not that hard. And then it's just mostly, it needs to get approved it needs to get discussed by the encoding working group, which happens within a couple months typically. It needs to get approved at the UTC, which happens again within a couple months. And then there's the Unicode kind of timeline, which takes like a year or two, depending on how prioritized it gets, just to publish approved characters.
So I think, unfortunately, we're at the end of our time. So do come up and talk to Anusha and Aman. So let's thank our speakers again.
Stop the recording.